Hey yo, got another video example here for you. So in this video example, we are told that we have the two functions as shown below. F of x equals 1/2 times 2 to the x, and g of x equals 5x plus 2. And we got to find out what is the largest integer value of x such that f of x is less than or equal to g of x. So remember, an integer is just our counting numbers, one, two, three, and it includes all of our negatives and zero, of course. Um, so we're going to go ahead and set up a table. I think that'll be the easiest way for us to kind of see what's going on. So I'm going to have our x column, our f of x column. Oh, sorry about that. Let me erase that real quick. F of x column, our g of x column, and then we'll just have a true or false column. And I'll explain that when we get to that part, all right? So for x, let's just start with 0 and kind of see what's going on in our scenario. So all I'm going to do, I'm going to plug in 0 where we see x for my f of x. So 2 to the 0 is 1 because anything to the 0 power is 1. So now we have 1 times 1/2 is 1/2. And then we'll do the same thing for g of x. We'll plug in 0 for x. So 5 times 0 is 0. We add 2 and we get 2. So we can see that f of x, which is 1/2, is less than or equal to 2. That is true. So I'm going to put true. And so I'm going to erase all that stuff that we did. And then I'm going to go up to the next integer. So the next integer that we have is 1. So I'm going to plug in 1 here for x. 2 to the first power is just 2. Half of 2 is 1. So I'm going to put a 1 there. Again, x equals 1. So we're going to have 5 times 1. 5 times 1 is 5. And 5 plus 2 is 7. So f of x, which is 1, is less than or equal to 7. That is true too. So I'm going to put a true there. So let's go and erase that. We'll go on to our next one. So the next integer that is larger than 1 is going to be 2. So we plug in 2. So 2 squared is 4. Half of 4 is 2. So I'm going to put a 2 here. X is 2. So we're going to have 5 times 2. 5 times 2 is 10. And 10 plus 2 is going to give us 12. 2 is less than or equal to 12. That is true. So I'll put a T. And we're just going to continue this on, right? So I'm going to go up to 3. And let me erase all this stuff right here. And we'll do 3. So when we plug in 3, we have 2 to the third, which is 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So this whole thing is 8. Half of 8 is 4. Remember, x is 3. So 5 times 3 is 15. 15 plus 2 is 17. And 4 is still less than or equal to 17. That is true. And we're going to continue, right? So what is the next integer that is larger than 3? 4. That is right. So I'm just going to change the color so we can clearly see each row. So this is 4. So I'm going to plug in a 4 here. So 2 to the 4 is going to actually give us 16 because 2 times 2 times 2 times 2. So this will be 16. And then 16, half of 16 is 8. So I'm going to put an 8 here. And then we're going to plug in 4 because x equals 4. 5 times 4, which is 20. And then 20 plus 2 will give us 22. So now we have 8 is less than or equal to 22. And that is true. So as you do more of these, you're going to recognize that you'll eventually see some patterns. So when I look at my f of x, Every time I can see that this is going up by times 2. So 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So just with that pattern alone, what is my next number going to be? That is right. So we do get 16. And then when I look at this one, each time I can tell that we're adding 5. So 2 plus 5 is 7. 7 plus 5 is 12. 12 plus 5 is 17. 17 plus 5 is 22. And if I add another 5, we get 27. So this will be step 5. So if you notice, 16 is still less than 27. So that's true. And from here on out, we could really just use our pattern. So here, if I go to 6, we're going to multiply this times 2, which will give us 32. Now, if I add 5 to this, we get 32. And is 32 less than or equal to 32? That is a true statement. So I'm going to put true. All right, and let's do it again because we don't have a false yet. So when I go to turn 7, we're multiplying this times 2 because that's our pattern. We get 64. I'm going to add 5 here. We get 37. And let's check to see if that is a true statement. So I'm going to erase this right here. And we have 64 less than or equal to 37. So is 64, is that less or equal to 37? It's neither, right? So that's a false statement. So when I go back to the question, it says, what is the largest integer value such that this is still true? The largest integer that made it true was 6. So my answer would be 6. All right, so in this problem, definitely start off with the substitution, right? Then once you do enough of them, if you're still getting trues, then keep going, recognize what the pattern is, and then you can save yourself some time. Definitely hope this video helped.